Greetings to you all. In this video, we are going to discuss about Quicksort algorithm. Quicksort is a sorting algorithm based on the divide and conquer technique. The technology behind this divide and conquer technique is breaking down the big problem into smaller subproblems and solve all the subproblems and then combine the solutions to get the final solution. This quicksort takes an array of values. Select one of the values as pivot element and moves the other values so that lower values are on the left side of the pivot element and higher values are on the right side of the pivot element. For example, in this array, let us consider this 5 is the pivotal element. So, all the other elements 8, 3, 4, 9, 10, 7. The elements which are smaller than this 5 will be kept in the left side and all the other elements which are greater than this 5 will be kept in the right hand side. So what are the items or values which are lesser than this 5? 3, 4. Okay. The elements which are greater than this 5 is 7, 8, 9, 10. So now 5 is in the appropriate position. So this is the main concept of this quicksort algorithm. So the steps. Okay, the first you have to choose a pivot element from the array. Next step, partition the array around the pivot. You have to partition the array. And after partitioning, of course, all elements smaller than the pivot will be on its left and the elements which are greater than the pivot will be on its right. Okay, the pivot will be in its correct position. And we obtain the index of the pivot element. The third step is recursively apply the same process to the two partitioned subarrays, left and right of the pivot. Okay, when this recursive procedure will stop, you know, recursion is the technique of calling the function by itself repeatedly. So, of course, you must have a condition to stop the recursion procedure, okay, or recursion call. So, the recursion will stop when there is only one element left in the subarray because the single element is already sorted. So, these three are the three steps in quicksort algorithm. Choose a pivot element, partition the array around the pivot, and recursively apply until you get only one element in the subarray. So choice of the pivot. So as we know, there are many different choices for picking the pivotal elements from the array. The first one is, okay, always picking the first or last element as a pivot. Okay, pick the first or last element. Okay, so here first either you can select this 5 as a pivot or 7 as a pivot. Okay, the problem with this approach is it ends up in the worst case when the array is already sorted. So this you can check. When you give the input of the array already in ascending order, then definitely worst case may be occurred. Then next choice of pivotal element is picking a random element as a pivot. So this is a preferred approach because it does not have a pattern for which the worst case happens. So here the random element, either you can choose 8 or 9 or 4 randomly. You can select any random number as a pivotal element. And the third choice is pick the median element as a pivot element. Okay, this is an ideal approach in terms of time complexity as we can find median in linear time and the partition function will always divide the input array into two halves. See, listen. So here you have an array 5, 8, 3, 4, 9, 10, 7. So you have to find the median of this array. Median of this array. Of course, this will have the time complexity in linear time. So how do you find the median? Okay, add ascending. Arrange these numbers in ascending order and the center number will be the median. So 3, 4, 5, 7. Of course, there are 7 numbers. Okay, so this is the median. So this can be a pivotal element for the quicksort. Partition algorithm. Next. Okay, so we have chosen the pivot. After that, you have to partition the given array into two hops, okay, or two subarray. Yes. So the key process in quicksort is partition. So this is you have to write the algorithm to partition the given array. So there are three algorithms to partition the given array. Okay, there are three approaches or three different algorithms are there. All these three algorithms have order of n time complexity, of course. So naive partition, then Lomuto partition, then horse partition. So, and here in this video, we are going to apply this horse partition. Anyway, what is naive partition? Let us, in this approach, we create a temporary array. Okay, then copy the array. You have to copy the given array. Maybe if A is the given array, you create a temporary array B. Then copy all the elements, okay, to this B. And first put all the smaller elements, then all greater elements. Then copy the temporary array back to the original array. So this is naive partition. So Lomuto partition in this algorithm, this is very simple algorithm. Here we keep track of the index of smaller elements and keep swapping. When you find the smaller elements, you can swap the pivotal element with the smaller elements and it proceeds like that. Okay. But horse partition, this is the fastest of all the partitions. Okay. Here we traverse the array from both sides. So if you consider this is an array, you will traverse, okay, from this to this and also from end to front and front to end. So both direction you will check the numbers, okay, with the pivotal elements. So and keep swapping when greater element on the right, it's smaller on the left. Okay. So here horse partition. And complexity analysis of Quicksort, there is an extra information to you, so no problem. So of course, time complexity, you have three categories: best case, average case, worst case. Okay. So in best case, when the pivot element divides the array into two halves. Okay. When you have that median as a pivot element, you will get a best case. Okay. Omega n log n. An average case, theta n log n. So when the pivot divides the array into two parts, but not necessarily equal, two parts, then this is average case. Then worst case, okay, is order of n squared, n squared. If you have 5, then you will have worst case computations 25, pi squared. So when the smallest or largest element is always chosen as a pivot, in that case, worst case may appear. So quicksort algorithm, here input, you are giving array A of 0 to n minus 1, left index L and right index, okay, R. So L, R. Output, okay, output, it will give a subarray of L, R sorted in ascending order. Ascending order, this is quicksort. So here, okay, here a subarray or array, okay, array. L, comma, R sorted in ascending order. Okay. Algorithm. Quicksort. A, L, R. A of the array A, lower limit. Sorry, this is left and this is right. Okay, left, right. So when L is less than R, for example, here you have some 4, 3, 2, like 8. Okay. So here this is L and this is R. So as if this L is less than R, then partition. Okay. Divide this array into or split the array into two parts. Okay. So L, for example, if this pivot element is 5, you may have this 5 here and 2, 3, 4, 6, 8. So this as the right position. So this yes, okay, yes. Yes is the position, the correct position of the pivotal element. This partition algorithm will return the position of the pivotal element, the correct position of the pivotal element, pivot element, right? So here again you have this subarray and this is another subarray And here this is L and this is of L R. So this is 0 R. So again 0 less than L less than R. L less than R. So 0, 1, 2. Okay. So it proceeds. So the quick sort A, so L, okay, L lower limit, S minus 1. Okay, this is S. Okay, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5 index. So the fifth one, okay, 3. So this is the index. So here A of 0, comma 2, this is one subarray and next array is S plus 1. So 4, comma 5. Okay, so limit 4 to 5, then 0 to 2. So this is one subarray and this is another subarray. So you should keep on dividing this into 2, this into 2 until you get single element. So suppose 2, 3, 4 you may get, because 2, 3, 4 is already in sorting order. So anyway 2, it is proper position, 3, 4 and 3 is the pivotal element. So 3 is already in proper space, only 4, so 2, 3. So subarray. So what this partition algorithm will do? It will return the index of the appropriate index of the pivot element. And then this quick sort for left subarray and quick sort apply quick sort for right subarray. So recursion. Again it calls. So first this will be completed and next this call will be completed. So the given array is 5, 3, 1, 9, 8, 2, 4, 7. So here L is 0, R is 7, pivot element is 5, that is A of 0, 5. So now to keep track of in this square set partition algorithm, we are moving from left to right and also from right to left. So to move from left to right, you are having the index variable I. To move from right to left, we have the index variable J. So I is incremented, J is decremented. So I is incremented whenever A of I is less than the pivot. J is decremented whenever A of J is greater than pivot. If it is less than, if it is A of I is greater than pivot, stop. Okay, stop. If A of J is less than pivot, stop. So now I compare 3, I is incremented. So 1. So compare, this is less than. So move, I is incremented. So now I is this. Okay. So less than, move. So this is greater, stop. So I. So now I is here. I. So stop. J, decrement. 7, greater, decrement. So 4 is less than 5. So stop. So J is J. Okay. So now interchange this 9 and 4. So here 4, 9. All the other elements are same. Okay. So now I has the value 3. J has the value 6. I. Next, I is incremented. So 4. Here the value is 8. So 8 is greater than 5. So stop. So now I is, so J 9. So 9 is greater than 5. So decrement J. So 2. So now 2 is less than 5. 2 is less than 5. So stop. I and j. Next, you have to interchange this ith element and jth element. So here 2, here 8, 9, 7, 4, 1, 3. Okay. So now 8. So next, I is incremented. I is incremented. So now 8 is compared with 5. 8 is greater than. So stop. J is decremented. So 2 is less than 5. So stop. But here I crosses j. So now the value I is greater than j. So you have to swap the element a of L and a of j. So here a of L. So 2 and here it is 5. 3, 1, 4. Here 8, 9, 7. Okay, so now stop. So 5 is the pivot element has got its appropriate position. The index return j. So here the j is 4. J is 4. 4. It will return. So this is one subarray and this is another subarray. We have to sort this and sort 8, 9, 7. So to sort this, okay, so again, this is I, okay, this is jth position. So here for this subarray, L is 0 and R is 3. And for this subarray, L is 5 and R is 7. Okay, no problem. R is 7. So now 4, 5 has got. So 2, 3. So I value 2, 3. Here I. Okay, I. This is greater. When this is greater, stop. And here J. J is 4 and 2. This 4 is greater, decrement. So here J. Okay, 1. So 1 is less than, stop. So I and J, interchange. 1, 3, 4. Here 2. Okay, the remaining 5 has got its position. No, so you have to sort only this. So now I is here and j is here. So j. Now I incremented 3. So this is greater. So greater means stop. So now I comes here. J. So j 2 and 3. This is greater. So decrement. So j. So now it crosses. If it is crosses, A of L and A of J has to be interchanged. So 1, 2, 3, 4. Okay, so now 2 has got its position, 2. So now the S value is, for the second partition, the S value is 1. So this is one array and this is the subarray. So sort this. So already this one is in only single element. So write it. 1, 2. Here 3 and 4. So next this. So 3. So 3 is compared with 4. 4 is greater. So already in ascending order 3, 4. Okay. So let us write here 5. We can have 5. So now sort this array is array 8, 9, 7. So this is I and this is J, Jth position. So 9 is compared with 8. 9 is greater. So stop. Then 7 is compared with 8. So 7 is less than, stop. So interchange this. 7, 9, 8. Okay, so I, J. So increment I. So I will come here. So 9. 9 is greater than 8. Stop. J. So J has to be decremented J. Okay, so when it crosses, you have to interchange 8 and 7. So 7, 8, 9. Finally, you will get 1, 2, 3, 4, 5, 8, sorry, 7, 8, 9. So the final array is in sorted order. That's all. You just work it out again, then you will understand how quicksort algorithm works. Thank you.